Dear students, see the next question from 11th standard, Unit and Measurement chapter, Ncert exercise question 2.27. It is actually additional question. Okay, see the question. Estimate the average mass density of sodium atom, assuming its size to be 2.5 Armstrong unit. Okay, so sodium atomோட size கொடுத்திருக்காங்க. That is 2.5 Armstrong unit. So generally size means considered as a radius. Okay. So the radius is given, that is 2.5 Armstrong unit. So I can write as, that is a 2.5 into 10 power minus 10 meter. Okay. Use the known value of Avogadro number. So Avogadro number, Avogadro number 6.023 into 10 power 23 mole. Okay, right. Then the atomic mass of the sodium. So that atomic mass of the sodium is actually 22.9 something will come. So I'll take 23 gram. Okay, that is I can write as 23 into 10 power minus 3 kilogram. Okay, right. So compare it with the density of the sodium in the crystalline phase, 970 kilogram per meter cube. Okay, ஒரு crystalline structure கொடுத்துட்டாங்க. அந்த crystalline structure same sodium only. அது சோடியமாக மாறினதுக்கு அப்புறம் crystalline மாறினதுக்கு அப்புறம் அதோட density what is it, 970 kilogram per meter cube. Okay, so are the two densities of same order of the magnitude. So நாம கண்டுபிடிச்ச value, I mean initial state இருக்கிற density of the what is it, sodium, that density value, then the crystalline structure density value, whether it is the same or otherwise the same or same magnitude, like that something asking. Okay, right. So this is the question. So our aim, first you want to find the density of the what is it, sodium atom. Okay, so first you should find the density. Okay, so what is the density formula actually? So the density is equal to mass by volume. So mass, no problem, it is 23 to 10 power minus 3 kilogram is there. So volume want to find, so that is our first aim. Okay, so you find the volume. Yes, see that volume, first volume. So volume formula, that is a 4 by 3 then pi r cube. Okay, so now I can write here, so volume is equal to 4 by 3, pi value 3.14 into radius. Radius actually what, 2.5 into 10 power minus 10 meter. Okay, so this value already I simplified. Actually this is the volume of the sodium atom. Okay, so the volume of the sodium atom. Okay, or simply I can write as VA, volume of the sodium I calculated, that is 65.42 into 10 power minus 30 meter cube will come. This is actually the sodium of the volume of the sodium atom. Okay, right. Then the next one, this is actually the volume of single sodium atom. Okay, but we are going to calculate for mole. Okay, so the volume of the sodium atom for 1 mole. Okay, so volume of sodium atom for 1 mole. Okay, per mole how many molecules are there? 6.023 into 10 power 23 molecule. So for that much molecule is there. So each and every volume, that is 65. So volume of sodium atom into Avogadro number. So volume of sodium atom, that is 65.42 into 10 power minus 30 into Avogadro number 6.023 into 10 power 23. Okay, so this is I can write as, so already I calculated, so I can write that value directly. That is a 3.9 into, yes, 3.9 into 10 power minus 5 meter cube. Okay, so now that the volume is increased because this is 10 power minus 30, this is 10 power minus 5. Okay, right. So now we are calculated for that sodium atom volume for 1 mole. Okay, now we are going to calculate what is the density. So we can calculate density. So density of that sodium atom for what is it, for 1 mole. Okay, so I can write the density is equal to mass by volume. So mass value, mass value given, that is 23 into 10 power minus 3 divide by volume. Volume, that is 3.9 into 10 power minus 5. So after simplifying, I can get this value, that is density is equal to 590 kilogram per meter cube. 590 kilogram per meter cube. Okay, but if you observe that this is like a sodium atom. Okay, so the sodium atom density only 590 kilogram per meter cube. But after the formation of crystalline form, so actually the crystalline form means actually what? So when it is converted as a crystalline form, so here the strength will be, that means interatomic molecule distance will be reducing. Okay, the strength will be increasing. So it will be close to each other. Okay, so that means what? Actually, density is equal to mass by volume. Okay, so for the crystalline form, they gave the density value what? Actually 970 kilogram per meter cube. But here, as an atomic form, its density 590 kilogram per meter cube. So that density value is converted as 970 kilogram per meter cube. Because it is converted as a crystalline form, this interatomic molecule distance will be reducing. That means interact together. Okay, so the density is increasing. At the same time, volume is reducing. Okay, so that is the reason here for change into the crystalline structure, volume is reducing, the density is increasing. So that increasing density only, that is 590, what is it, 970 kilogram per meter cube, that is in the crystalline phase. Okay, but the order will be same. This is actually both will be 10 power 0, 10 power 0 only. That means 970 here, 590 here, 970. Okay, so there is anything in 10 power. So order will be the same, but the magnitude wise is changing. Okay, that means the density is increasing. Okay, students, thank you.